Amica Insurance, Auto, Home, Life, Integrity. Proud sponsor of Forces of Nature.
Planet Earth, 4.5 billion years ago. A blazing sphere formed by colliding cosmic matter. A violent world, covered by a sea of molten lava. Over time, the surface cooled into a rocky crust. Great clouds of water vapor rose, then rained down, forming a vast ocean. The crust fractured into huge, moving plates that shifted the emerging continents, producing the face of the planet we know. But the forces that created Earth still rule it. Around the globe sweeps a volatile atmosphere. And within, a fiery world still burns. Floating on this semi-molten interior, the plates of the crust are forever in motion. Only in a thin layer between the inner heat and the atmosphere could life arise and thrive, yet always at the mercy of these colossal forces. Erupting from the depths, shaking the solid ground, descending from the sky. We cannot control such power, but we can use our human powers of invention and discovery to learn, to understand, and to survive. There are places where primal forces are still on display, where lava streams freely from the Earth's interior. Yet these same forces can also erupt suddenly, unpredictably, with terrible consequences. For hundreds of years, the volcano called Soufriere Hills on the Caribbean island of Montserrat was dormant. But in 1995, some 12,000 islanders discovered they were living on a time bomb.
The situation has escalated. This followed a major ash fall at just after 8 o'clock this morning.
The scientists have told us that they can no longer guarantee 6 hours notice.
All incoming data are being processed on a near real-time basis.
Because the volcano can just go off with little or no warning.
Deadly cascades of ash, gas, and lava rocks, called pyroclastic flows, raced down the mountain at temperatures as hot as 1,000 degrees. The eruptions continued, burying the capital of Plymouth under ash. But there was time to evacuate the population of about 4,000, and no lives were lost here. Yet outside the city, pyroclastic flows killed 19 people who had ignored the warnings. For scientists, this place has become a kind of living laboratory. At the Montserrat Volcano Observatory, Dr. Marie Edmonds is part of a team from the British Geological Survey.
I became a volcanologist because we know so little about these dangerous mountains, and I saw that studying them could mean better forecasts of eruptions, which could save many lives. I sometimes feel like the volcano is almost a living thing. It grows, it breathes, it even has a kind of pulse. I grew up wanting to be an astronaut or a spy, but living alongside an active volcano is just as exciting. Right now, there are signs the mountain is building towards another big event. We feel a great weight of responsibility on our shoulders, but it's difficult, trying to figure out what might be happening miles below in the crust of the Earth. Montserrat is actually the peak of an undersea volcano, which was built up by a collision between two plates of the Earth's crust. As the heavier plate plunges beneath the other, intense heat and pressures melt the leading edge into magma. The magma rises into a chamber and then heads towards the surface. If it reaches the surface quickly, it can generate enough gas to explode. Smaller explosions continued here, and during the last couple of years, thick magma has built a 500 megaton mountain above the vent, a huge lava dome. We believe it will collapse, and that it will trigger more explosions and potentially dangerous pyroclastic flows.
The first hint of danger comes when seismic instruments show increasing swarms of earthquakes, a sign that magma is rising, causing tremors within the volcano. Routine monitoring takes on a new urgency. They need to check the instruments designed by Marie that constantly monitor gases rising from the volcano.
We've discovered that if the volcano suddenly exhales more gas, it can mean that the activity is ramping up to an eruption. So today, the volume is up, and that's a worrisome sign. Next, we have to fly as close as possible to the crater of the volcano to get more data and to evaluate the situation. This is one of those times when the research we conduct is a bit risky, especially for my partner, Richard Hurd. One of his jobs is to install a laser reflector, which can measure even a few millimeters of ground deformation. That can tell us if magma is filling the chamber below and causing the ground to swell. We avoid dangerous situations unless it's absolutely necessary. Too many researchers have died in recent years because eruptions surprised them.
All of the evidence suggests that the dome is increasingly unstable. The collapse seems imminent. Warnings from the scientists convince the government to begin evacuations. On a July night, it happens. Violent eruptions sent ash clouds rocketing 10 miles high. Because of the warnings, not a single life is lost. Ash still falls occasionally, but most have learned to live with it.
Most likely, the eruptions will pause for a while, then begin a new eruptive cycle. But as long as we continue to monitor the volcano, and as long as we continue to unravel its secrets, there's no reason for anyone else on Montserrat to be harmed or to lose their life. And that in itself is reason for celebration.
What scientists learn in Montserrat could help reduce risk for millions of people living near volcanoes around the world. But there is another kind of event caused by forces below that is even harder to predict and far more dangerous. Among the places at greatest risk is a heavily populated part of Turkey, where shifting plates of Earth's crust meet along a 1,000-mile seam. It's called the North Anatolian Fault, and it can produce a sudden catastrophe, one of the deadliest of all natural disasters, an earthquake. If we could pull the plates apart and descend within, we'd see that 10 or 15 miles down, they begin turning into extremely hot, putty-like rock, sliding in opposite directions atop the semi-molten interior farther below. Somewhere along the fault, the plates lock together, and over long periods of time, enormous pressure builds. Eventually, they break loose and rip past one another, unleashing powerful waves of energy that race through the crust, shaking the surface above. Nearly atop the fault lies one of the world's great cities, Istanbul, Turkey, which has been jolted by earthquakes across recorded history. In the heart of the city, one remarkable structure has remained standing through 14 centuries of quakes. The Hagia Sophia is an enduring marvel of art and architecture. But for one man, it's also a treasure house of geologic history. Geophysicist Dr. Ross Stein has spent more than a decade studying earthquakes in Turkey, trying to find ways of forecasting when and where they will strike. Here, he found a critical piece of the puzzle.
When I first learned that since ancient times, the clerics of Hagia Sophia kept records of their earthquake repairs, I was tremendously excited. Because with such a chronology of quake dates and damage, combined with other data, we might discover a pattern that could help us forecast quakes. Such a discovery is every scientist's dream, and in some ways, it came true. It turned out that 11 major quakes in the last 60 years had occurred in a largely westward progression, and I kept asking myself why. We went out to take a look at each quake site, and we began to form an idea about how built-up stress, where the plates are locked, suddenly gets moved during an earthquake. We turned our data into a computer model of stress being transferred by a quake, with red showing where stress increased along the fault and blue where stress was relieved. Suddenly, the puzzle pieces fit together. With each quake, stress didn't just dissipate, but moved down the fault, where it concentrated again. And in most cases, a major quake struck in the red zone where stress had increased. Our model suggested that the next great quake might strike Hizmet, a city of more than 200,000 people.
And on August 17th, 1999, disaster did strike. The Hizmet earthquake was a magnitude 7.4 and lasted 45 seconds. An eternity to those who suffered through it. Local news crews captured the aftermath as rescuers searched for thousands of people trapped under the rubble. "20,000 buildings were destroyed. 500,000 people left homeless." Some believe the death toll reached as high as 25,000. The real toll may never be known. The loss of life was caused in large part by substandard construction. In many places, cheaply built modern structures lay in ruins next to undamaged ancient mosques.
Almost immediately after the quake hit, the international community arrived with food, medicine, and shelters. Most of the residents are choosing to rebuild in Hizmet. But if the lessons we've learned here aren't acted upon, their future is not bright. The most important thing we can do is to build safer structures. And we know how. We just have to make it a priority. What I want to do is to improve our ability to forecast when and where an earthquake will strike. We calculate that stress has now reached a segment of the fault beneath the Sea of Marmara. Sadly, this area where the next major quake is most likely is just 10 miles south of Istanbul, a vibrant city of some 10 million people. To give these millions of people a warning just before a major quake hits, seismometers have been placed near the fault segment we think is most likely to rupture. Warnings could reach Istanbul a mere 10 to 20 seconds before the violent shaking waves arrive. And the hope is that people will have a few moments to get themselves and their families to a safe spot. It's almost impossible to convince people that they have a serious earthquake problem to contend with unless they get some kind of dramatic warning sign. And for Istanbul, Hizmet was that warning.
The earth-shaking forces beneath us interrupt life only occasionally. But unfolding constantly above us is the clash of great forces we know as weather. The fluid gases of the atmosphere can unleash devastating power. This is home to some of the most severe storms on Earth. A Midwestern region of the United States known as Tornado Alley.
Conditions are pretty favorable for some explosive thunderstorm development. In fact, some that's going on right now. There's going to be a threat of severe thunderstorms, large hail. Storms continue to intensify. Take your tornado precautions. Do it now.
On May 3rd, 1999, an extraordinary series of tornadoes ripped through Oklahoma and left behind almost unimaginable destruction.
As I remember 2x4s snapping, just snapped like toothpicks, you know.
Everybody says, you know, what do they sound like? And it sounded pretty much like a freight train. But you were underneath the train.
The house was gone, and I haven't found the refrigerator yet.
I looked out across the street, and I said, there's no houses across the street. I can see until 4th Street.
Many survivors were warned in time, thanks in part to an unconventional team of scientists. It was these Doppler radar trucks, venturing close to the 1999 storms, that clocked the fastest wind speed ever recorded near the ground, 301 miles per hour. Dr. Joshua Werman and his team spend months each year chasing tornadoes, hoping to get a radar's eye view inside them.
For For a long time, I've dreamed of solving the biggest mystery about tornadoes, how they're born. My goal is to get a three-dimensional picture of the wind speed and wind direction within the storm. But first, we have to position our two trucks on different sides of the storm at roughly a 90-degree angle and be in just the right place as a tornado begins. We don't know exactly how a tornado starts, but we do know what precedes it. Here, warm, moist air from the Gulf of Mexico rushes upwards through cooler air, forming a thunderstorm. Some of the rising air cools and sinks, or is dragged down by rain and hail. The warm air racing in at the bottom can actually push on the higher winds aloft, sort of tilting them and forming a large spinning column. Somehow, down near the ground between the air rushing up and the air rushing down, the spinning dramatically intensifies. The thing that fascinates me is that only some storms spawn tornadoes. If we could figure out which ones, we could warn people earlier. That's why we drive about 10,000 miles every spring. Most of the time, we miss the tornadoes. It's incredibly difficult. I've been trying for years.
Apparently the Weather Service is saying this storm is capable of producing softballs that's 4.5-inch hail. I don't know if I buy it, but I thought I'd pass that along.
Near the end of one recent season, the team received word that a violent storm was developing, one that might spawn an outbreak of tornadoes. The challenge would be getting there in time.
Okay, both cells look pretty good. Both have hooks on them. The western one looks like it has a better hook on it now.
It's a drill they've been through many times, one fraught with frustrations. An empty gas tank, empty stomachs, inevitable indigestion, and unpredictable delays. This day would prove even more eventful than usual.
The shoulders are a bit muddier than I had expected. I tried to rock it back and forth, but it went backwards and is quite stuck.
The storm was coming right at them. All they had to do was get unstuck.
Rotation is just about due west of us, still at about, I'd say, 5 kilometers, maybe 4.5. Where's the rotation relative to you? It's moving directly toward us. There's no reason to panic on this, right? Not yet. Are you unstuck? Yes, I'm stuck. Okay, we're seeing increasing rotation at low level. Now, Sue would concur with that.
After years of near misses, Josh Werman's team was in perfect position. And this storm was cooperating.
I'm looking at it. We got one now. We're getting it right now.
first time ever, the team succeeded in recording with 2 Doppler radars conditions within a storm at the moment the tornado formed. The data will take years to analyze, but it promises to help unravel the secret of how this tornado was born. It was a victory for science, for Josh Werman and his crew, and for those whose lives will one day be safer because of their efforts.
As scientists, we yearn to witness the unknown, to see things that have never been seen before. Hundreds of years ago, that would have been new rivers or new islands. For me, that unknown is the inside of a tornado.
Working to decipher powerful events like a volcanic eruption is really searching for patterns that will alert us when something terrible is imminent, so that every human life at risk can be saved. Only 19 people died here on Montserrat, but that's 19 too many.
Several 100 million people live along the world's most active earthquake fault zones. So it's critical we get better at forecasting quakes.
If these and other scientists can add a little bit to our understanding, then one day the pieces will fit together. And we have that power to explore, to learn, to find ways of surviving, no matter how powerful the forces that confront us.
Seems you're going northeast now? Hey, give me a wide lens. Give me the 40 or something. Going increasingly north, continues its present path. It will be rounding over towards us. 40 millimeter? Yeah. Unlock! 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 Open it. Unlock it! Unlock!